Hello everyone. In this session, the objective is to describe the conceptual backgrounds of projections which are used in the projected coordinate system or the so-called the planar coordinate system. Previously, we noted that the Earth is really big. Not only it is big, but it is a big round spherical shape called a spheroid. A globe is a very common and very good representation of the three-dimensional spheroid Earth. One of the problems with the globes would be that they're not very portable. That means you cannot carry or you cannot fold a globe and put it in your pocket, and their small scale makes them of limited practical use. To overcome these issues, it is necessary to transform the three-dimensional shape of the Earth to a two-dimensional surface like a flat piece of paper, computer screen, or a mobile device display in order to obtain more useful map forms and map scales. This is what we exactly call the process as the projection. So let us enter to the domain of projections. A map projection systematically projects locations from the surface of a spheroid to representative positions on a flat surface using mathematical algorithms. Projections are made onto geometric shapes that can be flattened without stretching their surfaces. These surfaces are denoted as developable surfaces. Just to illustrate the process, uh, imagine that we place a light bulb in the center of a translucent globe somewhere here. On the globe are outlines of the continents and the lines of longitude and latitude that are called as a graticule. When we turn the light bulb on, the outline of the continents and the graticule will be projected as shadows on the wall, ceiling, or any other nearby surface. This surface itself is called as a developable surface. There could be some examples, others also. Uh, Cones are the classical developable surfaces. Cylinders, as we have looked into the system already, and the planes are so called the azimuths. Now let us go through the classification of map projections. One is based on the properties to be preserved. It could be a conformal, equidistant, equiarea, or true direction kind of projections. Other one is based on the developable surfaces. It could be a conic system, it could be a cylindrical projection system, or the planar system. Well, let us try to understand one by one. Based on the properties to be preserved, uh, the first one is something called as a conformal projections. They preserve local shape, must show the perpendicular graticule lines intersecting at 90-degree angles on the map. This is kind of a unique property as far as conformal projections are concerned. The other one is equal area projection. The equal area projection, it preserves the area of displayed features. To do this, the other properties could be distorted. They could be shape, angle, and the scale. The third one is equidistant projection. The equidistant projection preserves the distances between certain points. The scale is not maintained correctly by any projection throughout an entire map. Let us go to the second system, the classification based on developable surfaces. The first one is called as the conic tangent system. Just observe the developable surface. The second one is called as the conic secant system. I think you can visually see kind of intersection which is possibly present here, which is not there in the tangent system. The third system is called as a cylindrical system, where you have normal, transverse, and oblique cases. The last one is the azimuthal or the planar system, where polar, equatorial, and oblique cases. They have unique systems to be highlighted. Just to summarize, the map projections, they refer to the methods and procedures that I used to transform the spherical three-dimensional Earth into two-dimensional planar surfaces. That means a PCS is obtained from the projection of GCS. Planar projections use the plane, cylindrical systems use cylinders, and conical projections use the cone under the variety of cases like transverse and the normal conditions. Up next, the video would be something related to the UTM projections. Thank you.